So welcome back again, guys. So for this video, we are going to have our experiment number 2 about, again, Python, but on its literals and operations. So to start with up, let us open the IDLE and let's wait and maximize that. So the objectives: to become familiar with the print function and its formatting capabilities, to practice coding strings using literals, and to experiment with Python code using various operators. So background about literals, integers, floating point, boolean values, operators, all of them we are going to tackle in this video. So for the materials, we have our computer and the Python, of course. So let's start. Step 1. Create a source code for the given scenario below. Write a one-line piece of code using the print function to produce an output shown below. So we are expected to have this output, so let us copy. So print function, instead of double quote, let us use single quote, so we don't have any confusions, and enter. There you have it. As you can see, syntax error, invalid syntax at M. But how can we resolve this? I put a note in lesson learned. So I learned that backslash is a very important symbol for it not to appear invalid. So you can see the one that makes that is this. So we have to copy it, but this time before that apostrophe we must put backslash. There you have it, not invalid anymore. So let's run it. There you go. Code, I am code learning code Python code. So it ran the I am learning Python. So next, number 2, observe the output for each exponentiation arithmetic operation. So for this arithmetic, let's copy, Control C, then Control V, then let's put some commas, then enter. Oh, sorry, I have to enter. There you have it. So 2, 3, then 8. So what can we conclude here is that it is not division but rather exponential. So it was, this one indicates something that is raised to a power of this. So if 2 is the base, it was raised to a power of 3. So 2 raised to 3 was 8, and 2 raised to 3 also is 8, but with a 0.0, as well as 2 point raised to 3 is 8, 2 point raised to 3 point is 8. So we can see that it was also followed by none. So what can we hypothesize about this? The first line printed the answer 8, an integer form there, an integer, while the second up to the fourth function printed the answer 8.0, a float form. Lastly, the fifth line printed 4 nonce inside the parentheses. So as we can see, these are float numbers and these are integers. So number 3, observe the output for each multiplication arithmetic operation. So done with the addition. So let's try this. Enter. Oh, sorry. So there. 6, 6.0, 6.0, 6.0, and 4 none. So the same thing just happened like in number 2. The only difference is changing the number of 8 to 6 and also the use of double asterisks into a single asterisk only. So thorough observation. So observe the output for each division arithmetic operation. So we have now division. So let's try this division. Oh, division there. Oh, surprisingly everything was a float form 2.0. So all of the answers 2.0 are present in float form followed by 4 nuns. So that's it. Then for the fifth one, observe the output for each integer division arithmetic operation. So let's just copy this, then control V, just erase. Let's see. Ooh, combination of integer and float with 1, 2, 3, 4, 5, 6 nuns. So let's take a look at this. So 2, 2.0, 2.0, 2.01, 1.0. So 6 backslash backslash 3, 6, then 3.6 point, then 3, 6 point, 3, 6, then 4, 6 point, then 4. So we can notice that these two are indifferent, the first and the fifth one, the first and the fifth. And the only difference I see is that this point, which makes it float. So I can say that the ones without float are integers and the results also are integer, and the one with floats are floats and the results will be floats too. So that's it. So number 6, imagine that we used backslash instead of double backslash. Could you predict the results? So let's try this. Let's try first the double backslash. Let's try first the double backslash. So without any modification, let's try it. So negative 6 backslash backslash 4, then 0.6 backslash backslash negative 4. So both resulted into negative 2, but the first one was, of course, because this is integer, so integer answer also in float, then float also. But we can see 6 over 4 is something like 6 over 4 is 1.5, and backslash rounded it off. See, the function treated it as a division sign, therefore the quotient of the expression was the result. So division but with rounding off. Number 7, observe the output for each remainder arithmetic operation. So it was with a percentage this time. Oh wait, before we go, I forgot something. We haven't tried it using this single backslash, single slash rather, slash, I'm sorry. So single slash, delete, single slash, enter. Oh, see that? 6 over 4 or negative 6 over 4 is actually 1.5, but here it was really the division sign, since without any rounding off. But double slash, there is a division with remainder. That's the difference. So going back for the number 7, let's print this. Oh, sorry. There. 14. Then percent 4 is something like 14 divided by 4 is 4, 8, 12, but a remaining of 2, and that is here. Then 12, 4.5, 9, 9 to 12 is something to be remainder of 3, 3.0, because again, the principle of integers and boolean, and float are still here. And on the number 8, observe the output for each addition arithmetic operation. So let's see. Backspace. And going to enter. So negative 4 plus 4 is 0. Probably correct. Negative 4 point plus 8 is 4.0. So because of point again of the float to float. Negative 1.1, so it's just a single number with decimal, so it's also negative 1. And still the none is there. So just like on the previous trial. So exercises. What is the output of the following snippet? So let us print this snippet and enter. So my answer was 16, 8.0 and 8. So still 16, 8.0 and 8. So there you have it. Again, this is not multiplication but rather an exponential. So 2 raised to 4 is 16. This one is the multiplication. 2 times 4 point is 8, but 0.0, even though we don't need that 0.0, still it was always present as long as it is a float. And lastly, 2 times 4 is 8. Okay. So another snippet. Let's try this snippet. There, negative 2 slash 4. So slash is a division, so negative 0.5. Then 2 slash 4 is 0.5. Then 2 slash 4 is 0. Why 0? Because it rounds off the division answer, the quotient. But we can say that 2 divided by 4 will be probably 0.5 also, but the rule is on a double slash, rounding is rounding down. So if the answer is 0.5, round it down to the nearest integer, and that is 0. Then negative 2 slash 4 is negative 1, because negative 2, so that is negative 0.5. So rounding it down, it's not 0 but 1, because negative 1, because negative 1 is lower than 0. And the last snippet, we're almost done. Enter. There you have it. 2% negative 4. So it's negative 2. Yeah, that's correct. 2% 4. So the first one was negative, so the second one was positive. And lastly, this is something like more complex, but in order to prove, let us have our calculator. So if this is exponential, so we can say that this is 2 raised to 3 raised to 3 raised to 2. So there, 2 raised to 3 raised to 2. So when we enter it, we should have 5, 1, 2, and calculator says 5 1 2 also, so it's probably correct. So my conclusions are: operations like addition, subtraction, multiplication, and division results like the one on a calculator, and you can still have other options such as rounding it too. A certain result, especially in numbers, may contain or not contain decimals, which depends upon the rule of integers and float form. Lack of basic knowledge upon typing a code, like having no single backslash, just like on the previous one on the very beginning. Let me recap it. This one, my lesson learned, the backslash. So that's it. Backslash there. Backslash might result to a thought that it was an error or invalid, but the reality is not if we just manipulated it. And my recommendations are: always be careful, especially in a single missing character that might give you the assurance to run the code effectively. I suggest to always look for possible solutions for any type of problem encountered. And that's it. Our experiment number 2 about Python literals and operations. I hope you learned something, and thank you for watching. That's all.